we're going to evaluate the integral from 0 to 1 of square root of 2 minus x squared. You have probably tried by now all possible combinations of u substitution, and none of them have worked. The only way to find an antiderivative of this function is by a technique called trigonometric substitution, or trig sub, and that is taught in the early part of Calculus 2. Since we have not learned it yet, we cannot use it. Another alternative for us is to use the limit definition of the definite integral. Here's what it would look like. Integral from 0 to 1 of square root of 2 minus x squared dx is equal to the limit as n approaches infinity of sigma I equals 1 to n, and then the square root of 2 minus I divided by n squared, and then on the outside times 1 over n. This limit again is impossible to evaluate for us. So the only option we have learned that we can use so far, is what I call geometric option. Take a look at this integral, 0 to 1 of square root of 2 minus x squared. Let's look at this function. Let me call y square root of 2 minus x squared. If I square both sides, y squared is equal to 2 minus x squared, or x squared plus y squared is equal to 2. We recognize this as a circle with center 0, 0 and radius equal to square root of 2. In fact, if we retrace our steps and go backwards, the function we're integrating is the upper semicircle of that circle. So let me draw a picture here. And here is the upper semicircle. Its radius is square root of 2, so this is minus square root of 2. This is square root of 2, which is approximately 1.41. This is the graph of the upper semicircle, y equals square root of 2 minus x squared. And we're integrating from 0 to 1. So it is this region, the integral. This integral is just the area of this shaded region that you see right here. Let's examine this closer and see how we can evaluate that area, how we can find that area without using calculus at all. So the key is this point right here, the point of intersection between the vertical line x equal to 1 and our semicircle. The semicircle, or the circle, is x squared plus y squared equal to 2. So if x is 1, that makes y equal to 1 also. And I can break up the region if I connect the origin to the point 1, 1 into two parts. This is part A and this is part B. Note that part A, the area, is just an eighth of a circle. The entire circle has area pi r squared, which is 2 pi. If I divide that by 8, I get pi over 4. And then a region labeled B is just a triangle, a right triangle, with base 1 and height 1, so its area is 1/2 1 times 1, which is equal to 1/2. And now the problem is solved. The integral from 0 to 1 of square root of 2 minus x squared dx is just equal to pi over 4 plus 1/2.